Hi, I'm Courtney Gilmore, and I'm going to be talking about Experiment 4, titled Rates of Chemical Reactions. So, in this presentation, I'll be discussing the purpose of this experiment, the experiment itself, the results of the experiment, and then discussing the results. The purpose of this experiment was to obtain a rate law and calculate the rate constant of the reaction, as stated on page 54 of the lab manual. Another purpose of the experiment was to also see how concentration and temperature affect a reaction. So the reaction we're going to be looking at is permanganate solution plus oxalic acid solution goes to products. So before starting the experiment, a few pieces of equipment needed to be collected. That included test tubes, a rubber stopper, stopwatch, cuvettes, Spectronic 200 spectrophotometer, deionized water, permanganate solution, and oxalic acid. Also, before the experiment was started, the Spec 200 was prepped and zeroed using a blank of deionized water, and concentrations and room temperature were also recorded. So to begin, a solution was mixed following page 57 of the lab manual. A timer began when the solution was being mixed, and the cuvette of that solution was placed into the Spec 200, and when T percentage just passed 25%, the timer was stopped and the time was recorded in seconds in the results table. This procedure was repeated until two trials fell within 10 seconds of each other. Then, after experiment 1 was completely done, experiment 2 could go on, meaning a different solution was mixed and all the procedures were followed again, and then experiment 3 as well. So the result of this experiment showed that the concentration of permanganate, the stock solution, was 0.13 molarity, and the oxalic acid stock was 0.755 molarity. The room temperature was 24 degrees Celsius. Throughout the reaction, it started purple, and then when removed at 25% absorbance, it was orangish in color, and then went completely clear when the reaction was complete. The table on the slide shows the time of reaction in seconds. The table shows each trial for experiments 1, 2, and 3, and then shows the average time in seconds of the trial. This table on this slide shows the concentrations, rates, and rate constants of experiments 1, 2, and 3. The calculations used to get those values will be displayed in these three slides. First, the second and third columns were calculated using the equation stock molarity times the milliliters in the solution times the total volume of the solution. So, for example, permanganate in experiment 1 was calculated to be 0.011 molarity. This answer was then used to find the rate of the reaction, the equation for that being concentration in molarity divided by average seconds. So in experiment 1, the rate was calculated to be 4.63 times 10 to the negative fifth meters over seconds, molarity over seconds. Next, the order of the reaction was calculated using rate 1 divided by rate 2 set equal to molarity 1 divided by molarity 2, all to the power of x. This was found for both permanganate and for oxalic acid. For permanganate, the two concentrations that were different between experiments 1, 2, and 3 were used, and then the corresponding rates. For oxalic acid, the concentrations that changed, that were different in experiment 1, 2, and 3 were used, and then the corresponding rates were also used as well. So, the rate in respect to permanganate was found to be 1.4, and the order in respect to oxalic acid was found to be 0.7652. So all of these answers were then used to combine to find the rate constant K. The initial rate law was set up to equal K times the concentration of permanganate to 1.4 power times oxalic acid to 0.7652 power. Then a rate was put on the left side to solve for the rate constant K of 0.0025 1 over molarity times seconds. So, just to discuss what this purpose of this experiment was, the rate constant was found to be K equals 0.0026, and the initial rate law was used to find the concentrations, rates, order, and then finally to find the rate of 0.0026 times the concentration of permanganate to the 1.4 power times the concentration of oxalic acid to 0.7652 power. Here's my reference, and thank you for watching.